Hey, today we're going to talk about 7.4, Atmospheric CO2 and Particulates. So take a moment, check out the Enduring Understanding, look at the learning objective, pause the video, review the essential knowledge, and set up your Cornell notes. Okay, so this video, it's kind of, I don't know why the College Board has its own. We have talked about atmospheric CO2, we have talked about particulates. So this may be a little bit of a review, but there might be some, a little bit of new information. So, here we go. So I'm going to talk about some common natural sources of atmospheric CO2 particulates, but also other substances as well, or other chemicals. First of all, lightning is a major natural source that is involved, and I just wanted to reiterate that it does convert atmospheric nitrogen to NOx's. It is a form of abiotic fixation, so it will go to nitrite, NO2, and then nitrate. You know, that was part of the nitrification, but the abiotic fixation, it fixes atmospheric nitrogen directly to NOx's. And then it joins into the nitrogen cycle. Forest fires, the combustion from the forest fires can contribute a number of atmospheric air pollutants. Carbon monoxide, particulate matter, which is the black soot. We also see NOx. Carbon dioxide is released in the combustion of anything. And also we have water that is being released. Now it's water vapor. It's not like you're having a fire and you're having liquid water come out. There is water vapor released during combustion. Okay, cellular respiration, which hopefully you know the equation, you know the formula, but we're releasing carbon dioxide from the glucose, and we are also obtaining energy in the form of ATP. 30% of the atmospheric carbon dioxide comes from cellular respiration from biotic organisms. Conifers are natural sources of volatile organic compounds, and I've mentioned that before. And specifically, they're terpenes. That's what they're called. They have that scent, that kind of like pine scent is from the terpenes. Also, ethylene is present, and ethylene is also present. It is a gas that is released when fruits ripen. So not just conifers have ethylene, but also fruits when they're ripening will also give off ethylene. And that ethylene gas actually triggers other fruits to also start the ripening process. Because of these VOCs that are released from all these conifer trees, the Great Smoky Mountains, which is a park in the Appalachians, has kind of, the reason it has smoky mountains is because of this is photochemical smog that occurs naturally as a result of the high amount of VOCs that are released from these conifers. Volcanic eruptions. Volcanic eruptions can release sulfur dioxide, particulate matter, carbon monoxide, nitrogen oxide, and also carbon dioxide. Now, the amount of carbon dioxide that is released, while it may be significant, it is definitely not as much as the other sources of carbon dioxide, but carbon dioxide does still come from volcanic eruptions. We also have decomposition. Decomposition is going to either release carbon dioxide or methane. Now, decomposition is in an aerobic environment is just bacteria or whatever the decomposer is releasing carbon dioxide through respiration. So it's basically the process of respiration when we have aerobic decomposition. In anaerobic decomposition, the glucose is converted into methane. Methane is released in the absence of oxygen. Anaerobic decomposition happens anytime you have a flooded area that gets covered, an area that gets covered with water, and then the decomposition starts happening under the water. There is no air or very little oxygen, so it is releasing methane. Also, anaerobic decomposition occurs when permafrost is melting, because the permafrost has been frozen for thousands of years, and when it melts, you have a layer of water that's on top of the organic material, and that organic material starts to decompose in the ambient air temperatures, and oxygen is not very present or prevalent, so you have anaerobic decomposition releasing methane. The oceans account for about 40% of the atmospheric carbon dioxide. Remember that carbon dioxide dissolves in water and forms carbonic acid, or H2CO3. And the carbonic acid or carbon dioxide is not very soluble in water, so it will easily leave the solution as well. So you have you have carbon dioxide cycling between the atmosphere and the ocean. Because a large portion of the Earth's surface is covered by ocean, that's why we have 40% of the atmospheric carbon dioxide comes from the ocean. And just one thing I wanted to point out, the ocean holds 50 times more CO2 than the atmosphere. That's a lot. All right, so again, a geologic carbon source is volcanic eruptions. However, only 0.03% of all the atmospheric carbon dioxide does come from volcanic eruptions. So even though it is a source of carbon dioxide, it is not the major source of carbon dioxide. And just to remind you, we have this Keeling curve, and this Keeling curve is taken in Mauna Loa Observatory in Hawaii, where it's an area that's pretty secluded, and they can get accurate readings of carbon dioxide levels in the atmosphere. And this is like the like an average. And remember that in the summer, the CO2 will in the summer, the CO2 is being pulled into the plants, so the levels will be lower, and in the winter there is no or very little photosynthesis happening, and the CO2 remains in the atmosphere. So there's going to be peaks and valleys in this Keeling curve. Again, in the summer, the CO2 levels will be lower because they're being pulled into the plants through the process of photosynthesis. Okay, and then some sources of particulate matter. We've talked about this, but sea salt, parts of the sea salt can kind of flake off, and the salt can become airborne. So that is a source of particulate matter. Dust, secondary sulfate. Sulfate that is released from the combustion of coal. We can have pollen. A lot of people are allergic to pollen, so the pollen becomes airborne when it's rustled up by wind or by insects, and it can enter your nasal passages, causing a lot of people to sneeze. You can have black carbon, or the soot from the wildfires, and then finally volcanic ash is also an example of a particulate matter. Okay, for your FRQ practice, students want to conduct an experiment to determine how road construction impacts the amount of particulate matter in the air. They spread Vaseline onto the bottom of 6 petri dishes and place them at various distances from a road construction site and an existing road. The first 3 dishes were placed 50, 100, and 200 yards from the road construction site. The second group of dishes were placed 50, 100, and 200 yards from an active road that is not under construction. So I want you to identify the control group used in this experiment, and I would like you to identify the likely dependent variable the students are measuring and describe how they could measure this variable. So I hope that this video was informative. It was, hopefully a good portion of it was review. I thank you for your attention. I will see you soon.